Hi, you guys. This mini lecture is on lipids. So we've talked about carbohydrates, we've talked about proteins, and this is a little bit about lipids. So here's good old Homer eating his triglycerides. And so when you think about a triglyceride, you're thinking about three chains of fatty acids. So really simple. If you think of it in a real simple fashion, you have a fatty acid 1, fatty acid 2, fatty acid 3, like in the picture here, attached onto a glycerol. Okay, that's what a fat is. That's what a lipid is. So if you add a little bit more information onto that, you would see that that glycerol really is a 3-carbon chain with its OH and H is attached. So it's 3-carbon chain. And then these long fatty acids that are what? Lots of carbon, lots of hydrogen. And remember, it doesn't maintain that ratio of for every carbon in a carbohydrate, CHO is such that you have equal numbers of oxygens and equal number of carbons and double the number of hydrogens. You don't have that here. If you look at this, you have lots of carbons and very few oxygens. So without really knowing what this is, if I showed it to you, once we get more practice with it, you're going to know that it's a fat because that ratio of carbon to oxygen is not maintained. Okay, so long fatty acids attached onto a glycerol. That's how you're going to recognize a fat. If you look at one now with a little more detail that we're adding on, there's the glycerol. There are the 3 chains of fatty acids. Do you have to know how to write these out? No, you have to know how to recognize them. So we've talked about dehydration synthesis a couple of times already with carbohydrates and with proteins. Here, it's the same thing. You have dehydration synthesis is occurring when you lose water. In this case, it's 3 molecules because we're bonding each one of the fatty acids. So 1, 2, 3. So 3 water molecules are lost. You've made that bond and you have formed a triglyceride. Let's look at more pictures of these and what they look like. As a definition here, so that you have it written down, dehydration synthesis links 3 fatty acids to a glycerol molecule, forming the triglyceride. Sometimes what you can see is a kink in the chain. So look, very straight here, carbon-carbon, full of hydrogen. Carbon-carbon-carbon-carbon, full of hydrogen. What's happening here is that it's saturated. What we mean by saturated is that it is saturated with hydrogens. It's full of hydrogens. If you were to do something like share an extra electron, a double bond with another carbon, then you wouldn't need another hydrogen there. You double bond a carbon with another carbon, you wouldn't need an extra hydrogen. So therefore, it is not saturated with hydrogen. If it's not saturated with hydrogen, then it is an unsaturated fatty acid. So notice that here I'm telling you the fatty acid contains at least 1 double bond. Yes, because that double bond is between those carbons. And therefore, here I needed more hydrogens, but I don't need a hydrogen if I'm sharing an electron instead with another carbon. This then is going to cause a kink in this chain, this bending in the chain there. So you would be able to recognize if I showed you this molecule without the oil picture there and said to you, what is this? Well, you know there's very few oxygens, so it can't really be a carbohydrate. Here, there seems to be a kink in this chain here, so it's got to be an unsaturated fat. Okay, and you would probably recognize the glycerol, which is just 3 carbons. This is just showing the same thing over again. Saturated, lots of hydrogens surrounding those carbons. What happens when we lose one and have a double bond? You get a kink in the chain. It's showing you an unsaturated fat. Your book has these pictures. They're all from your text, so it's really helpful to look at them. Bacon is a saturated fat, correct? It has all the hydrogens in it, so it makes it solid at room temperature. An unsaturated fat tends to not be solid at room temperature. That's how you would tell it apart. And there it is. There's one with each one of those fatty acids has a kink in the chain. In other words, they have a double bond, and they are unsaturated. What are trans fats? So this comes up a lot, right? And a trans fat is something artificial. I'll just read this to you. The vast majority of trans fats in our foods are manufactured by adding hydrogen. So you add hydrogen bonds to these unsaturated fats, and it makes the fat more stable, so it doesn't spoil as quickly, so it has a longer shelf life, so it can sit at Safeway for longer. These are not particularly healthy. So if we took an unsaturated fat and blasted extra hydrogen into it, then it would take on that extra hydrogen and it would become solid at room temperature. So you have some of those frostings on some of those cupcakes that are originally oils that they have saturated in order to make them solid at room temperature. Margarines do that too. The last one I want to show you here is steroids. Steroids are also lipids, they're also fats. So how would you recognize a steroid? Cholesterol is the other example here that I'm showing you. This one's cholesterol, and this is testosterone. Okay, so when you have these rings, 3 rings with 6 sides and one with 5, 3 rings with 6 sides and one with 5, you're talking about a fat still. And it could be cholesterol, it could be a steroid. You won't need to recognize that. It's just a fat, and maybe I'll give you a choice. Is this testosterone? Is it a carbohydrate? Is it amino acid? And you'd be able to say that it is either cholesterol or testosterone, and it's a fat. Okay, that's the end of my fat mini lecture.